Hello. In this video, we are going to be talking about an interesting idea called L'Hopital's rule. And L'Hopital's rule is a way of finding limits that are kind of tricky and limits that we wouldn't be able to find normally using what we've learned about derivatives. So L'Hopital's rule is something that you do when, well, you have some limit as x goes to some value. I'm just going to call it k. It doesn't matter. Of some function f of x over another function g of x. This is what we're trying to find. L'Hopital's rule applies when you just plug in k for f of x and g of x, you get f of k over g of k is indeterminate. So that's our main condition. What does that mean? Well, what are indeterminate values? So I'm going to make kind of like a little box. Indeterminate. What are some indeterminate values? Some indeterminate values include 0 divided by 0, infinity divided by infinity, and negative infinity over infinity, or vice versa, whatever. So these are indeterminate values. You could also think of them as ambiguous, and you can find a different video on that. I'm not going to talk about ambiguity, the indeterminates in this video. I'm taking that as prior knowledge, but obviously, just from looking at these, you can't just say what the answer is, right? You can't divide infinity by infinity. You can't divide 0 by 0 or negative infinity by negative infinity. It's not like any of these are going to become 1, right? Or negative 1. So what you have to do is use L'Hopital's rule when you have that f of k over g of k is indeterminate. So basically, and I'm going to write out the main conditions. These are going to be the main conditions. If we have the limit as x goes to k of f of x, and that is equal to 0 or plus or minus infinity. Well, I think there's a better way of expressing this, because I do want to separate these out a little bit. So basically, if the limit as x goes to k of f of x equals 0, and the limit as x goes to k of g of x is equal to 0, then there's one more condition, then something magical happens. So the one last condition is that and the limit as x goes to k of f prime of x, so the derivative of the function f of x over g prime of x, is equal to some real limit. I'm going to call it capital L because I think that's kind of a formality with limits. You call them capital L, and the idea is that this is some constant. It's some real value that we can determine. Then that means that this value here is equal. So then I'm going to write this. Then the limit as x goes to k of f of x over g of x, not prime, f of x over g of x, is also equal to L. Is also equal to that same value L. So we have to have it that they're indeterminate, like 0 over 0, and we have to have that the limit of the quotient of their derivatives is equal to some real constant limit that we can determine. Then that limit is going to be the same as the limit of the quotient between those two functions. However, that's not the only condition, and I wanted to kind of say this all in one. Something is weird is happening here. But there's one more, so I'm going to include this indeterminate part here. there's one more condition. Also, this is just going to be my box. It says also. You can't stop me. Also, if the limit as x goes to k of f of x is equal to plus or minus infinity, and the limit as x goes to k of g of x, oh, where's my g? G of x is equal to plus or minus infinity, and I'm losing space. That might not be an entire infinity, but we'll see. Oh, it is. All right. And this is almost the same thing. And the you probably know where I'm going with this. It's probably quite obvious at this point. And the limit of the derivative of f of x over the derivative of g of x, f prime of x over g of x, is equal to some value L. It doesn't matter what that value is, right? I'm just writing L for both of them. Doesn't matter. L is just some number, some real number that we can determine. Then, wait for it, then the limit as x approaches k of f of x over g of x is also equal to L. So basically, I'm going to write this out in one more way because I think that this is the clearest way, though. Weird stuff is happening. I think that this is the clearest way of expressing it, but maybe not the most like mathematically pure. It's the way that you'll think of it when you're doing problems like this. Basically, the limit as x goes to k of f of x over g of x is equal to the limit of f prime of x over the limit. Oh wait, I'm doing this all wrong. What am I doing? My gosh, I'm a monster. Let's redo that whole thing. The limit of f prime of x over g of x, g prime of x, sorry, as x goes to k. But this has some givens. This is given that 1, this is part of the rule. This is basically 0 over 0 or plus or minus infinity over infinity. So that has to be, the rule is that that's one of those. That's one of the givens, that our normal limit is indeterminate. Also, if it wasn't indeterminate, why do you care? You can just find the limit, right? And this has to be, a real number. So it has to be something that we can actually determine. This has to be a real number. And, this actually has to be a real number in terms of how numbers are defined mathematically. This is a real number. But when you're solving problems, you usually just think of it like this, because this is usually an assumption of the problem, or else they wouldn't give you a L'Hopital's rule problem if that wasn't the case. Otherwise you wouldn't have to use L'Hopital's rule. I've never seen a problem that's a trick problem where you don't have to use L'Hopital's rule, but perhaps they exist. And it's assumed that you can find an answer, right? Most of the time. But keep those in the back of your head. But if you just look at this, if at least you get this, you can probably solve most problems involving L'Hopital's rule. But it is important that you know the actual definition, because in some cases, and I don't know if there are going to be questions about it, but it's good to know, it will be important to know that other information. In the next video, we're going to be going into a rather famous example, at least in some of my videos, of L'Hopital's rule, and I think that will be cool. So thanks for watching.